Hey everyone, welcome to the stream. All right. So last stream, which was just a couple nights ago, I was implementing audio, and by the end of the stream I didn't really have anything quite working, but after the stream, and I tweeted about this, I spent a little bit more time looking at my code, and I saw a couple of mistakes that I had made, which I can actually point out if you were paying attention. So there was a couple. One of them was the fact that, let me see if I can situate myself here. So yeah, there was a thing about, rather than paying, like, I have this computation where, hold on, it's kind of difficult to explain without things on screen. Yeah, I had done this thing where I computed the number of PSG, which is the sound chip, cycles per second by taking the CPU cycles per second and dividing it by 16. And then I was using that to figure out how many sound chip cycles I would need to elapse before producing a sample for the output for the audio driver. But it was actually incorrect for me to do that, because at least the way I coded it, rather than try to check the cycles based on the PSG, I was actually checking them based on the CPU cycles. So this gets clocked at the same frequency as the CPU, and the only place where we really do the every 16th thing is inside this checking the master divider, and that's used to update the tone generators. Now I may actually still change this. I may make it so that we only try to produce samples, because in any case, the signal coming out for the audio will be the same for 16 CPU cycles. So actually might be an optimization. But anyways, the point was I wasn't doing that, and I was basically producing samples too quickly. So I fixed that. The other big thing that really fixed something for me was that in the tone generator, I had some bad bit logic, like bit shifting logic, for setting the period for the period high and period low. Probably you can see it in my diff here. PSG, yeah, here it is. Like, it was just incorrect. First of all, I was shifting left 16 when I needed to be shifting left 8. That's the main part of it. I also just made sure, I don't think this was necessary, but I OR it with the original period, and I mask off just I mask in just the low bits. I don't believe that's necessary, but just to be sure, I think it's more clear this way. And for period low, I think this is the same. I just make sure to now mask in just the top. Technically it could be 0F because I only need this nibble over here, but it's okay. And then I OR it with low. But the most important one was this shift 16 here instead of shift 8, which was producing something that was almost right, but did not have the right pitch. Another thing that I did, that I had to do, which means there's a bug somewhere, is my volume code, I effectively disabled it. So this get channel volume here, I had this thing that I was checking the amplitude register. If it's fixed, then I return the fixed volume ratio. There's something wrong with this. And so what I do for now, just to kind of simplify the problem, is I'm just returning 1, and we'll have to revisit and fix this. But with this, and with my really bad resampling code, and I know for a fact that my resampling code is incorrect, and I'm gonna have to do something better for it. So that the code I'm talking about is over here, where I'm averaging my samples, and I'm this is a bit of a mess, but it's okay. It's kind of an approximation. But with all of that, plus the fact that my audio driver is able to output to a raw file stream, we actually can get something. So let me make you hear what I'm talking about. Okay, so I'll stop the music for a second. So let's say I start up. I'm going to start up Mindstorm. It's going to produce a raw audio file, which we're going to open in SoundForge, and we're going to listen to it. And as a basis of comparison, and I guess I should get that open. Let me Let me see if I can get that. I want to make you hear what it's supposed to sound like. Oh, and now actually we see a signal here. You see? There. That was supposed to be like dun da da, which is some kind of Vectrex intro song. And this is da 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 da. And then we come here. So let's say we stop here, okay? Now before I show that, let me get my, I had this YouTube video of the Mindstorm intro. Mindstorm Vectrex. Yeah, I think it was from this video here.
Monopoly Cheaters Edition. It's okay to cheat in this game, but get caught.
Great ads.
This is Mindstorm on the Vectrex, the built-in game on.
Let me see if I can. There. Okay. So. Okay, I think we're not gonna hear that. So I don't know if you heard that.
You're in trouble because that's an ominous opening theme song.
So it's da 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 da. Oh hey Moosey boy. Yeah, I'm doing all right on sound implementation. We're getting there, slowly but surely. So yeah, so what I want to share now is, here, I'm gonna just close these ones here. Let's open the raw file and, what just happened there? Whoops. No, not open, import. Import raw data. So the way the import raw data works is that you just have to give it the right information. Like for me, it's a 32-bit float, little endian, and it's mono at 44,100 hertz. So that's what I'm expecting to produce. So I'll make you hear that, just that part that we heard in the video, because you didn't actually hear the intro part. Moosey boy, were you able to hear that? Just want to make sure that the audio comes out properly. I know that my audio capture is not super loud for the audio that comes out of my machine, so I might have to raise that. I'll play it one more time. And so compare that with this here. So, you know, it's a start, right? Like it's obviously it's not perfect. That it doesn't sound exactly the same, and there are many reasons for that, and we're going to slowly address each one of these things. But definitely the shape is right. The timing is pretty close. You know, it's pretty right. It's pretty close. So there are things to fix. Actually, one of the things you can see it here. You can see that my audio is kind of off center, right? It's not actually, it should actually be centered around 0. It's all in the positive range, and there's a reason for this. I mean, first of all, I'm producing values between 0 and 1, and that's exactly what you're seeing here. So that's the first thing. And I need to effectively shift it. So that's one of the things I want to do. Yeah, thanks, Moosey boy. So let me make a quick list. I'm going to just update my to-do list because I'm going to forget things. And it just helps me kind of focus the things that I need to do. So let's come up here. And we'll say like sound or audio. So we'll say, so what I want to do there is, so produce sound in, or like correct, what do I want to say? Actually, I don't even know if I want to correct it at this place. I wonder if I should. I don't know if I should do it at the input level. Because it's kind of like two ways I can do this. I can make it so that my audio that I feed in is in the range of 0 to 1, which is sort of the contract that I have now. And then I can do a correction based on the type of format that we choose. Because when you create an audio device, you tell it what format you want. And for example, you can say, signed 16-bit or unsigned 16 and float 32. And apparently I read that the one that's supported by all drivers is signed 16. So what I should do is I think I'm going to keep my format for float values to be in 0 to 1. You know, like I'll say here values in range 0 to 1. But then what we'll do is we'll scale it correctly. And I think I even have a to-do about it in here. Let me see here. There's the type. Where was it again? I think it's an add sample. To-do. This multiply is wrong for signed format types. Yeah, so that's it. I'm just doing this kind of take it and multiply it by this max value. So this is wrong, and I want to fix that so that we get a properly centered sound. Hey, Mac Addict. Yeah, it's audible, but it sounds like 1 or 2 channels has a bit more volume than the original. Absolutely. That is 100% right, because I am fixing the volume at 1 right now. I'm not actually getting the correct volume per channel. There's a bug in my implementation, so that if I come back here in the PSG, and I go and I kind of bring back the code I had written for getting the volume from the amplitude register, just as a... So, and also be clear, I'm not really doing the envelope volume yet, and I don't know if it's using envelope volume. Could be actually interesting here if we just put like a little log, and we'll find out right away. Envelope volume not yet implemented. I'm just curious if we'll see anything there. Was it error F? I forget what it was. I just need to include where error F is. I don't even remember. Where is error F? Oh yeah, console output. Okay, let's just try it like this, and we'll see what we get. It's possible if it's using envelope, that's why it doesn't sound right. Oh, unreachable code. What's that? Oh yeah. And guys, let me know if you want me to raise the my audio output capture volume. There's a part of me that's kind of afraid to do that, because like if weird pops and glitches come out, I don't want it to freak anyone out. Oh yeah, so let me show my... See, I'm not getting any error Fs here about... I didn't get any mention of envelope volume, so I don't think it's going through there. It is, I think, only going through this path here. Now let's see what that actually sounded like. I'm gonna mute this one. Whoops. Well, whatever. Not sure if that was really audible, but first of all, you can see it's a lot less, obviously got a lot less volume. So it's not right. You can kind of hear the bass note in there, but there's something going on with the fixed volume ratio. There's just like a bug somewhere in here, and I just got to look at it. Yeah, I'm not sure. Get mode is fixed, yeah. Read bits, fixed volume, which is the 4 low bits of the amplitude register. Now, I read that. That should return a value from 0. I guess it's technically divided by 16 should probably be divided by 15. Is that right? No, yeah, that's right. 16 is fine. Right? But anyway, that's not really the mistake. The shape is wrong. So Not sure what's going on there. Maybe it's the amplitude register that's not getting updated correctly. Things to look at. So for now, I'm just going to put this back and we're going to investigate these things one at a time because I can't quite see what's wrong just yet. So let's do this. And let's make a short list of what I need to look at. So like correct, whatever, it's like, how do I say this? Shift output, shift signed samples to be centered around 0. Oh, and another thing too is the raw audio that we're capturing here isn't actually output, it's the input, which is why it's float and 0 to 1 and not the signed versions that I'm expecting to feed internally in the audio driver. And you can see it here, basically like in add sample float 32, I do this conversion for the target sample and I push it back on this list of samples. But what I actually pass to the raw audio output FS is the input sample. And I probably shouldn't do that. I could probably just feed it the sample that I'm outputting instead. And I might just do that. I might change this. And on that note, what I would like to do is output WAV file instead of raw file, just for debugging. Moosey Boy, random question that popped in my mind. Can you name 3 specific things that you learned while creating this emulator? That's a great question. Let me think a bit about that. Mac Addict, you ask, remember if the value is 0, it defaults to 1. The value is 0, it defaults to 1. You're talking about volume? So there's the amplitude mode, 4-bit fixed amplitude level. When fixed level amplitude is selected, it is fixed only in the sense that the amplitude level is under the direct control of the system processor. Varying the amplitude when in this fixed amplitude mode requires, in each instance, the direct intervention of the system processor via an address latch write data sequence to modify the D3 to D0 data. And when M is 1, the amplitude of each channel is determined by the envelope pattern as defined by the envelope generator's 4-bit output. The amplitude mode bit can also be thought of as an envelope enable bit, sure. Okay, yeah, so you're right that in some cases the value, like 0 means 1 and 1 means 0 or whatever. But in terms of volume, I mean, I guess that's true for the kind of the mode bit here, right? So, you know, fixed is M0 and 1 is envelope. So they actually say it here. They say when m equals 1, select variable level amplitudes, the amplitude of each channel. And then they say the amplitude mode bit can also be thought of more of as a envelope enable bit, right? If you think of it that way, then it's more like true false kind of thing. So maybe that's what you're referring to. But in terms of actual, like, I think my code is not wrong. And we see clearly that there is a change in volume, right? I'd love to you know what, let me do another capture because I like seeing the original. It kind of helps to see when it's not affected by volume, what it looks like. What's going on here? Oh yeah. You know what I'm gonna do? I'll just put them side by side and we'll see if we can get like a little hint about what's going on there. And I'm kind of loving this little output here. It's kind of neat. Even though like I can't, can't see anything. I know there's audio being produced. File, import raw data. So yeah, we kind of like you can see that this is where it changes. Yeah, the oscilloscope output. Yes, I love Audacity. And yeah, the oscilloscope output. And for that, I got to say I love what's it called, ImGUI, because I mean it was trivial for me to get that output, right? It was like one call in here somewhere, plot lines, and I just give it all the samples currently that I have, and that's it. It's pretty slick, and it's fast. I was worried, that it might be slow, but no, it handles it like a champ. I get like some 70,000 samples being rendered in there per frame. Amazing stuff. Okay, let me just continue to just flesh this out. So I want to do this because I think a WAV file would just be easier. I don't have to keep importing and setting values and stuff, although it's kind of secondary. But I think adding a little a WAV file header might be something easy. So look into why volume isn't working, amplitude, register, etc. Another thing that so right now I'm using this WAV file, and the reason why I'm doing that is even though I have everything hooked up, when I don't define this, we don't hear anything. And I thought about it, and I think I realized why we don't hear anything. It's kind of like, my idea originally was, in order to kind of keep things separate, I was like, similar to the way we do graphics, whereby at the engine level, I can show it here. See, like, we have this render context, and in there all I have is this vector of lines. And the idea is that every frame I pass in this render context, and the idea is that the emulator, the emulation core, at one point will populate that vector with the lines that need to be rendered this frame. And when we come back here, I pass that render context to my GL render scene here, and we render it, right? So that's kind of nice because it means that, if we're working on a different platform that doesn't support SDL or OpenGL, this is the one place where we change things, and the emulation core doesn't really care. Its job is just to return lines. Now, similarly, I thought, let's do the same thing for audio. Let's feed it an audio context, and the audio context will basically have a vector of samples. In this case, a vector of float samples in 0 to 1. And that every frame I would get those back, and I would iterate and pass those to my audio driver. But then I was thinking that I don't know if this works. What I worry about here is that because for sound, we need to kind of produce samples as fast as possible. We gotta like keep feeding samples as fast as we can, and I'm worried that kind of doing a full frame update and then afterwards feeding those samples and doing another frame update and feeding those samples, that we might end up starving the audio driver doing it that way. I could be wrong. I mean, I know my frame rate's pretty high, but that's one of my guesses as to what might be going wrong. And we should be able to verify that, because I have this thing here that I had implemented. This comes from when I wrote the stuff for my NES emulator, where what I do is I have this little control here where I pause the audio device until I have enough data. So until I have 50% of my buffer that's full of audio samples, and then I unpause, and then what that does is the audio driver starts calling, there's this callback that gets called, and it's down here, and it starts saying, like, fetching data from the buffer and feeding it, and using it to produce audio. And if if this goes too fast, then my buffer will drain to less than 10%, at which point I will pause, so that this stops calling and giving me a chance to fill the buffer. Now this is kind of like a simple solution, and it allowed, like on my NES emulator, what this was for things like pausing or running in slow motion. It allowed things to kind of just work, you know? And I think it's fine, but I'm wondering if that's what we're running into, that because I've got this like two-phase thing of like produce a bunch of samples and then feed the samples, rather than feed the samples during more evenly spaced in time, which is what I actually do on my NES emulator. Maybe that's what's happening. Maybe we're just like falling into the constantly pausing and not really feeding those samples to the audio output, to the sound card, you know, to the driver, whatever you want to call it. Because like if I put 0 here, we just don't get anything. So I'm just kind of guessing here. See, like I don't hear anything, and we should be hearing something because I'm feeding those exact samples. And I'm even looking, like I've got this here in Windows. Like there's no audio here, you see? It's not actually playing there. So I mean, we can kind of verify what's going on, because right now we're showing the sample that are going through the add sample function, but we're not showing what the audio callback's doing. And maybe I could do something in the audio callback to try to like flag that we are indeed reading, or maybe I could just kind of show when we're paused or unpaused. Yeah, maybe I could just do that for now. Let's just see. When the pause state changes, we'll just say audio. I'm going to go to paused. Let's see. Let's see what we get. Sorry, Moosey Boy, I missed a couple things there. So Moosey Boy, ImGUI is still immediate mode, right? Yes. Is there a simple way to check if SDL's audio is actually working, or did you confirm that? You know, that's also... So check this out. Pause and pause, but this is what I was worried about. And I believe it's because I'm splitting the two, and it's not the right way to handle it. So I think my guess is probably accurate. But you do make a good point. You know, if we want to just make sure that we're getting audio out of the sound card, can we actually do something about that? And I think we can. Let's try this. What could we do? We have a time-based approach. I guess we could produce a sine curve or something like that. At an input frequency. Let's say 44.1. But you know what? Before I do that, let me just make a note here. So look into why volume isn't working. Shift sine samples. And then here I'll say, so what I think I'm going to do, rather than do this kind of audio context thing, I think I'm going to have to pass in like a function or some kind of, you know, interface that I implement and that you call in to add samples. I think that's what I'm going to do. And then this way I can do it in real time. Just as soon as I can, I just add those samples, which was what I originally designed it to do. And maybe that just means I'll pass in like the SDL audio driver will implement some interface or something. So I think I'm gonna have to do that. So like replace audio context with some interface or function ref to add samples directly from PSG. So Musi Boy, you asked me before if I can name 3 specific things that I learned while creating this emulator. Man, I learned a lot of stuff creating this emulator. So just to reiterate, this isn't my first emulator, it's my second one. So yeah, it's my second one. My first one was the NES emulator. So I learned a lot of stuff there, and I kind of applied a lot of that learning to here. But the thing is with Vectrex and Vectrexy is that this has actually been a more difficult emulator to write for a couple of reasons. For one, I don't have as much documentation. So I had to really dig a lot more and really read a lot more about how the hardware worked, and read mostly from documents that date back from like the 1980s. You know, reading like, for example, for the CPU, I read this, I have this PDF of an old book written in the 80s about how the CPU works and how to program against the CPU. The CPU itself is more complicated than the 6502, the one in the NES. So it was more complicated, and I learned about how, like for example, implementing the interrupt system was more complex. What else can I say? Learning about vector displays. I had no idea how vector displays worked, and that was super interesting to learn. Like how in terms of the Vectrex, you know, you drive these motors, these integrators, in order to actually move the beam. So that was really interesting. I learned a lot about OpenGL. When I started this project, I really didn't know that much about like like writing shaders in OpenGL. I only kind of like, you know, I knew immediate mode OpenGL from like years ago. I know GL begin, GL end, and all that. But I didn't really know about how to write shaders, you know. So that's something I learned a lot about on this project. So that was really cool. So yeah, those are a few things I've learned, and there's a ton more, you know, like yeah, just like a bunch of stuff. I learned about Linux, and you know, I had ported to Linux, but like kind of the easy way of porting, which is just use SDL. But in this emulator, I went a little bit outside of that and wanted to give a little bit more of a, like my NES emulator on Linux doesn't have a way to open a dialog to load a ROM. You have to pass it in by command line, whereas on Windows, I open a dialog. For Vectrexy, I decided, no, I want to be able to open a dialog on all platforms. And I made use of a third-party library for that, which was fine, you know, and I learned a bit about that. It's I think it's this one here, knock file dialog. So that was kind of cool. ImGUI, didn't know anything about ImGUI. I just knew like of it. So on this project, I learned more about it and how to use it. So there you go, a few answers to that question, hopefully. So yeah, you were saying, can we just make sure, and I think that's a good idea, let's make sure that the audio driver is actually producing some sound. I mean, I guess at the very least, we could just output a tone. How about that? At 44 hertz. So what is that basically? We want the number of samples I have to produce is going to be like the delta time is in, let's say, seconds, and I have to produce a certain number of samples per second. So I'll divide. Yeah. So how about this? We'll take this off for a second here. And we'll say the frame time divided by the G audio driver dot get sample rate, which is going to be 44,100, but whatever. Const double. And we'll say num samples excuse me. And you know what, we'll just round this, it's fine. G audio driver dot add sample. So let's say we just produce a tone like this. Okay, let's see what that sounds like. I'm gonna put my, make sure here. And we are not producing anything. Why is that? I believe if you turn up the verbosity on SDL error, you can see what's initialized. That's true. Okay, so I'm getting 0 here. I've got a very small frame time. Oh, I guess I can't. All right, that's not going to work. Did I do this right? Seconds divided by samples per second is the same thing as multiplying by samples seconds per sample. Oh no, that's not right. It's multiply, right? It's basically seconds times samples per seconds will give me samples. Okay, let's try that. I am initializing the audio, and in fact, I think I'm kind of doing it twice. So I have init audio here, but I believe that my audio driver's initialization does the same thing. Am I like, yeah, okay, now I'm gonna start getting some samples. Okay, here we go. And let me remove the pause, unpause noise in here in the audio driver, because that's actually introducing a bit of delay as well. Actually, that's true. The printing to the console can be slow enough that it might even be exacerbating the problem. That's a beautiful sound, isn't it? Was it awful? Moosey Boy, was it really awful for you? I'm gonna try and produce a sine wave. I just want to see if it sounds okay. Not loud, just a horrible sound. Yes. I'm surprised it wasn't constant. So that's a little bit worrisome, I guess, because it should be fairly constant. I mean, then again, maybe it's because of the truncation. Could be that, you know, with a variable frame rate. Reminds me of the time I forgot to shield the motherboard from the flyback transformer. What, you got some like awful sound? CRT interference with the audio circuit. Ah, that sounds fun. Why do I use ++I? It's habit. Basically, because ++I is pretty much what you usually want for iterators, I basically just am consistent and do it for everything. You know what I mean? Oh, and this goes into the negative range. I should if I use cos, I guess it'll be positive. No, of course, it always does that. So what I'll do is plus 1 divided by 2. Yeah, so I always do the ++I thing because it's always consistent, you know? Like, since for iterators, you pretty much want to pre-increment to not, to avoid the useless return type from the post increment. It's the most efficient for objects. And so in C++, we do use iterators. And so it's from that, just kind of be consistent. I just always use pre-increment. And I only use post increment when I really mean to, when I really mean to get the value and then increment after, which is super rare anyways, in my, whoops. I think I just refreshed Twitch a few times there. Sorry about that, guys. I don't know if I missed anything there. I'm hitting F5 while I'm debugging, but my focus was on Twitch. Yeah, I don't understand why I'm not getting a more constant sound curve here. That's kind of disconcerting. Let me think. It's try something. I'm going to try and just keep the error amount and see if that produces a more consistent number of samples. But I don't think that's my problem. There's something else that's going on. I think it's really not doing the right thing. What the fuck's going on? So I have 4,410. So I have a bunch of samples to produce, and then here, this will become a small fraction. So I keep the fractional part. So that's basically should even out the number of samples over time. So let's try this. Instead of writing, okay, we're gonna do the output stream thing, but we'll write the output value, not the input value. I'm very curious. So rather than the input sample, do the target sample here. We'll see if we at least see the sine curve that we're producing. All right, so this time, I don't think it was signed. Was it signed 16? Whoops. Audio driver. Yeah, it was signed 16. I guess it's kind of being smart enough to figure it out. Oh, wait, let's do solo here. Yeah, that looks like garbage. And what about the float values? I'm supposing it's going to be the same. I must be doing something stupid. Big endian? Oh, so that looks actually like a sine curve. Guess that's what a slow sine curve looks like. Maybe if we make it a bit faster, it'll actually sound like something. It's true, like a 1 second period is probably not very good. Let's, or coast or whatever. Yes, I have built a noise generator. I think I'm done. I'll tell you this much. I am definitely not a pro when it comes to audio, as you probably can tell. But I do find it interesting. Okay, so what am I doing wrong here? First of all, I don't know if the endianness makes any difference for floats, but interesting. I guess it does make a difference. Ah, yeah, look at that. Don't really understand what's going on here. What am I putting my? Let me think here. All right. Yeah, no, this is not right. Yeah, it's on the outside. I gotta multiply. No. Having a bit of a brain fart here. What does I want to do? think it's here that I want to speed up my sampling. Okay. Let me see. I'll get there. That looks just as bad. What's up with the TCP.h in the project? So that was actually pretty cool. So that was related to when I was implementing my CPU, and I was getting to the point where I was having some difficult bugs to figure out. And I didn't want to like cheat by looking at the code of another emulator. So what I did was I did find a CPU emulation, like a implementation of the same CPU, and and I was able to plug it into my emulator without actually like looking at the actual implementation file, just kind of looking at the header file and its interface. And so what I did was I compiled my CPU against this other, I compiled my emulator against this other CPU implementation, and there were things that were working with it that weren't working with mine. So then what I decided to do was I was like, imagine that basically there was a way for me to compare my emulator to a real working hardware with another CPU, and I could compare the two, right? Now, of course, I can't do that because whatever, the hardware, and I don't have access to, there's no like serial port or anything where I could like figure out what's actually happening. So what I did was I compiled two versions of my emulator, one with the other CPU implementation and one with mine. And then I just used every frame. I would basically like collect a bunch of information about every instruction that I was executing. So like the state of the registers, all the memory reads and writes that were happening on the memory bus, stuff like that. And I would produce a hash of that value. And I would basically hash all this information for all instructions per frame. So let's say one frame would execute, I don't know, 1,000 instructions. I would basically produce this hash of those thousands of instructions. And one of the, over TCP, I would over a socket, one instance of the emulator would send its value to the other one. The other one would compare it to the one it had hashed. And for the most part, they would be the same. But as soon as I would run a frame where the hashes differed, both emulators would stop, like both instances would stop. And then from there, in my debugger, I could output the last frame's worth of instructions to a file in both cases, and then compare them. And this allowed me to hone in on where they diverged, right? And this is built upon the fact that my debugger is able to keep a running trace of all instructions, or the last million instructions or something, and I can dump them to a file afterwards and see what's going on. So I kind of built upon that to do this, and this really helped me figure out the last few places where my CPU emulation was wrong. Thanks, Moosey Boy. Yeah, I was pretty happy with it. It's cute. I haven't used it in a while because now my CPU is pretty much working. But you can see it's in this sync protocol here, and basically I just have a few things I gotta send, like frame start and frame end. Oh yeah, that's another thing that's really interesting, is in order to get the two to run exactly the same, they need to be like synced on frames, right? Like both have to run the same frame start and frame end. And part of that message is sending, for example, when I send the frame start, I have a server and a client, and the server says, I'm starting a frame with this much delta time, and here are my inputs. And on the receiving end, it gets that frame time and says, okay, well, I'm going to run this frame with the same frame time as you, and I'm also going to override my inputs and use the same inputs as you. So this allowed me to basically, like, using my controller, I could move my ship or whatever, and you would see on both instances they would both move at the same time. So that was kind of cool, and it was necessary for me not to diverge, right? I needed them to really be emulating the exact same inputs and the same frame times in order for things not to diverge, except when they would diverge because my CPU was incorrect. So that was really nice. So there are, you know, YouTube VODs on this. Not sure how to find them though. You're gonna have to maybe read the descriptions. At some point, I'd like to kind of go back and relabel, retitle some of my episodes or all my episodes to kind of give a hint about what I'm focusing on in them, or maybe make some kind of, you know, page somewhere that has all the episodes with the brief description, so that it could be easier to find this type of stuff. But someday I'll get there. All right, so what is it I'm trying to do here? I am trying, so maybe someone can help me here. I'd like to try and produce a sine wave here at a different frequency. And I guess I'm doing it wrong. I mean, it looks like I'm doing it wrong. It's interesting how this one here looked okay though. Did I not just produce one? This is why I want to produce a wave file. Now it says big endian. Okay, so that actually looks more like a sine wave, but you can see here some, I guess that's some kind of aliasing or something. Oh wait. Oh. What was I just not zoomed out enough or something to see these? Weird. Yeah, I think it's an aliasing issue there. It's partly that. Mm-hmm. Yes. I suppose that's what it is. I was thinking about sampling rates and maybe the Nyquist theorem, and I need to have a curve that's got twice the frequency, at least twice as fast, you know, twice the frequency of what I'm trying to sample. But it doesn't seem to be the case. This is one of those things where I get off stream and then I'll think a bit about it and go, oh, you know, that's right. But not seeing it right now. If you guys see it, let me know. Time to get the rubber duck out. Yeah. Exactly. Oh, I don't know if that's true, Moosey Boy. It's all like small steps, you know? Let me try something. Just thinking about maybe what I need to do is take the time from last frame and the next time, so like the target time, and divide it by the number of samples and sample through the, yeah, let me try. It's hard to explain it. It's easier to just code it sometimes, you know what I mean? So like, and you know what, I'm gonna leave it as going from negative to positive, because in any case that should center it around 0. And this won't be elapsed time, this will be elapsed time plus dt. And then I'll add a sample, and I might actually need to do this. Anyways, let's start with this. Double to float, yeah. Frame time is double, sample is double, right. Why does it say big onion? Okay, well that looks smoother. Right? Oh yeah, and that's the other thing too, right? Cos is in terms of 0 to pi, and I'm feeding it time. Right. Yes, Moosey Boy, you're right. You know what? I'm gonna go get myself a glass of water, and I will be right back. Sorry for the delay. I'll be right back. Hey guys. Yeah, sorry. I had to take care of something else. Input equals output. Yeah, so I have no idea what I'm doing. I'll stop my music. I just feel like I'm going in circles. Yeah, this really looks like when I'm trying to increase the frequency, I'm running into the problem of being unable to sample correctly. It's the Nyquist theorem problem, right? So I am producing a curve that's it. It's too fast. Like its frequency is too high. That when I sample it, that's it. My sampling has to be twice the frequency. Okay, it's the other way around. That's it. I need to sample at 44,100. So in order to reproduce this curve, no, sorry, the sampling has to be, what is it again? It's oh man, too long. Do I have anybody who knows about sampling here? Nyquist. The minimum rate at which a signal can be sampled without introducing errors, which is twice the highest frequency present in the signal. Okay, that's it. So in order to produce a signal that doesn't have error in it, if I am basically, I want to produce a curve that is at 44,100. Then I guess that means that my source signal can't be any faster than 22 hertz, right? Or something like that. That's right. Okay. Hey, somebody knows. 22 kilohertz. Yeah, sorry, kilohertz. Hey Pyro, how's it going? And Postal Rat. Have we spoken before, Postal Rat? All right, so I need my source sine signal to be no faster than 22 kilohertz, right? That's what we're saying? Yeah, poor Pyro. Pyro's in another time zone. Spoof H. Wow, that file organization looks terrible. Thank you. That's very nice of you. I assume you're talking about this? I mean, I think terrible is a strong word, personally. If you mean the fact that they're all these files for the emulator in one place, I won't completely disagree. I made an attempt once to start splitting this up, and then I gave up because it was too early in the project. But I will at some point start splitting this up. It's funny you should even mention it because I was thinking about it last weekend. But honestly, it's not that bad. Like, most of this, yeah, it's not that bad. At least I know my way around it. But there are places where, like, I want to split up some stuff into more files, and I'm not doing it because of the fact that it's all in one folder, and I know it's going to get confusing. So right there, it kind of betrays the fact that, yeah, it's not great. But I'm gonna reorganize this at some point. So what I'm thinking is, I was thinking about reorganizing it in a way that, you know, I have like an emulation core, which is its own library, and then I have a debugger that is a separate like the exe or something like that. At least I have a source folder. Yeah, it's not that bad. It's fine. Sometimes, you know, you got to keep it simple. It's not that big a project. I mean, what is this, like some 30 odd files here or whatever? It's not that bad. Anyway, okay. So Pyro, you're doing a night shift tomorrow night? Okay. So you'll sleep in kind of thing? So what am I working on? I'm working on audio, and right now I was trying to produce... I don't really need to do this. I know that... but it's kind of related to what I'm doing. It's about resampling signals. Right now I know that if I write all my samples to a raw audio file, it plays correctly, but it's not playing correctly through my sound card. And so, you know, to that end, I was like, hey, maybe I could just produce a simple sine wave, and we should be able to hear it, you know, through the sound card. It'll make sure that we've got things set up correctly, and then, you know, I can hook up the audio coming out of the emulated audio chip to come out of the sound card correctly. So Mac Addict, sometime during the refactoring the code that will happen probably, but until then, oh well. Yeah, about the reordering of code, for sure. I will reorganize this, and I have been thinking about it. But it's like, you know, it's a little bit like the reason why I don't spend time on that is that it's a little bit like, you know, trying to come up with the interface of your class before you actually start implementing your code. You know, I don't exactly know where everything should go when I'm making it. I don't know if I'm gonna be moving stuff around, and so I try to keep things as super simple and straightforward as possible. And then when things start to settle, then I can refactor things and make them make more sense. So that's, a lot of these things are settled, and I can already picture where things will go. And so yeah, it's kind of like it'll happen soon enough. But it's like I don't like to waste time on refactoring just for refactoring's sake. I'm in the middle of the development process of this emulator. Nobody else is touching it, and I know my code really well. I know where everything is. At one point, I will do it because other people will want to look at it and maybe use it or just learn from it. And I think it will be helpful as a learning tool to have things split up. But right now, for development purposes, I don't think it's helpful. It's just going to produce more friction for me, if that makes any sense. And frankly, it's just like physical files on disk, which is, not a big deal. Maybe the fact that all the files are in one place isn't great, but the organization of the code is pretty straightforward. The dependencies are pretty clear. So okay, so let me just think for 1 second here what I want to do. Mooball says, I actually prefer a flat hierarchy as long as it doesn't cause problems. Yeah. So I'll tell you what kind of things bother me, if you want to understand, if you want to see what I mean. So the GL stuff, for instance, right? Like, so there's a portion of my code that it has to do with the emulation itself, like the emulator core, I keep calling it, and that part doesn't give a crap about GL. So the GL stuff and the SDL stuff, like here, SDL engine, SDL audio driver, that's like specific to the platform. I'm running on a platform that uses SDL, and it also supports OpenGL, which may not be true for all platforms, and that has nothing to do really with the emulator core. And the way I've divided the code, none of the emulator core includes this stuff or cares about this stuff. So that shouldn't be mixed up in the same folder. It should be somewhere else. That would allow me to, let's say, go on another platform like a console or something and rewrite these parts, but the rest would stay the same. Another thing that bothers me is, let me see here, is the fact that, for instance, my debugger is a very large file. It's about 1,200 lines, but in here is stuff that I would want to move out. There's a whole bunch of functionality in here that I just like to move out, but the reason I don't move it out is because if I put this in a header file and another CPP, it becomes something that other files might, like it kind of becomes like a public dependency in a way. It's not a dependency, but it can be included, and I don't want that. So like, that's another thing that's kind of holding me back, is that whole concept of public versus private, dependencies, which C++ really doesn't give you like much help for that. How like if you work in other languages, like in C#, you can make modules, like you can make assemblies, and you can decide which parts of your assemblies are public and which are not. Like you can decide which parts are internal. That kind of control. In Rust, they have the same thing. You can make these, you can make crates, and you can decide what's pub in your crates and what's not. In C++, you don't really have that kind of control, and to try to emulate that type of thing is doable, You know, it's doable, but you gotta like do it kind of physically. I've seen one way of doing it is you kind of break things down into libraries, and you have, let's say, your public will be in your include, and then you can have, let's say, in source you might have other headers, and those are the headers that are private. You know what I mean? All right, Moosey boy. Thanks for hanging out. Postal Rat. I usually did audio in another thread. You know, sound will always play at some number of samples per second. You just need to fill the buffer as needed. You don't need to keep track of time. You mean in emulators? Have you worked on an emulator? I managed to do it with a single thread on my NES emulator, and it worked out pretty well. There is another thread. Yeah, okay, on games. Yeah, so there is in effect another thread though. Like there is basically, the way SDL works is you register a callback. That's basically going to run on another. Is it even going to run another thread? Not necessarily. It's going to kind of run on the main thread, but periodically. And basically, it's going to run. When it runs, you need to just feed it the samples that it wants. So that's the SDL model. It's pretty simple. Yeah, and it worked for me. It worked for. I'm going to try and keep it simple for this one as well. It should be fine. So yeah, anyway, that's what I meant. Like I would like to split up some files, and that's probably what I'm gonna do. Is I'm gonna have, let's say, a debugger module, and in there the public interface of the debugger, let's say the debugger.h here, that'll be the only thing in the include folder, and in the source folder I could create as many like I could split up files, and I could have headers and source files that are internal, if you will. And technically, another piece of code could go and, like, you know, nothing stops you from saying, oh, include debugger / source / some header, but that'll be a red flag, you know? So it'll be kind of like, don't do that kind of thing, you know what I mean? So yeah, eventually I'll get to that. So yeah, I'm not making much progress tonight, eh? Unfortunately. Oh no, that's not what I want to do. I'm not really sure how to do this. I'm gonna lay this to rest for just a second. I'm gonna put this in comments here. I'm going to come back to it, but I want to try at least to focus on this part here, and we'll see what happens, because it's kind of similar. So what I want to do, I think, let me see here. What do I want to do? Okay, I'm going to start with something like this. Let me just try. Let's see. I'm gonna eventually, I'd like to replace this with what doesn't actually exist in the standard, but I think they're gonna be adding it to C++20. It's called a function ref. Yeah, see, there's actually a, I think this is a paper that they're, oh, there's even function view maybe. I think there's different names for the same concept. Different people have been writing these things. And it's not super easy to write, but the idea is it's a non-owning view on a function, which is a lot faster than a std function, which basically type erases and has overhead. But anyway, we don't have to worry too much about that right now, I think. Okay, so let's say we do this. We set this here. Yeah, then I won't be able to plot these this way anymore, but that's okay. Let's get rid of that for now. Okay, so let's see what happens here. So no audio coming out. Oh, I heard something there. Yeah, we're definitely adding samples. Change that. That's probably not, it won't make a difference. Let me try something. Let me try removing. I wonder if I maybe messed up my computations here, because I have been messing around with the circular buffer, and I'm starting to wonder. No, I think this is correct. But just in case. Just want to kind of rule out. Yeah, not getting anything. And yet, oh no, wait. Oh no, it is turned off, right? Oh no, it's, I should probably turn that off. Oh no, that just decides whether it goes to a file or not. It's not a switch, so that's not going to make a difference, but let me put that back on. I thought maybe when I had that on I didn't produce audio, but that's not the case. Let's close some of these. See, like, this is what I'm hoping to hear out of our sound card. I can get rid of this crap. Oh yeah, so my audio callback's not even being called. Why is that? That's weird. I have this paused field that I'm not even setting. It's really strange. wonder if that's part of my bug. Okay, so I'm not able to keep up. So what if I put back my... Yeah, it's possible that I had garbage in the pause field, which meant that my pause logic wasn't working at all. So let's try this. If it was false and we set it to true initially, that should actually pause it. This basically, I just cache the pause state so that we don't wastefully, like, don't double pause or double unpause. So buffer usage is at greater than 0.5, so we do this. And then it dropped to 0.02. Now, of course, with the debugger, it's going to mess things up. So I don't know. I might have to do something to draw what's happening with these. But see, we're not hearing anything. No, I think this is right. I need to get, I need to understand whether this code, this pausing code, is doing what it's supposed to do. So I'm trying to think about how I want to do that. I think, okay, how about we do this? add an update function. And then what we will do is we're going to use imGUI. And I'll try and draw the buffer, and I'll color it based on whether it's below the threshold or above the threshold, just to see if I can get a feel for where it's at. Sometimes, you know, visualizing your data stream can be really helpful to understand what's going on. So this will be called once per frame. Now what do I use? Maybe not a progress bar, but maybe. There's a fraction. Yeah, I could maybe use this. Size arg for each axis less than 0, align to end. 0 is auto, greater than 0 specified size. Align to end. Okay. But this doesn't allow me to set colors, right? But maybe I could use the overlay. Okay, let's try this. So here as a fraction, we'll go and do the same thing we're doing in the audio callback. Sorry, no, not there. In the here. Get buffer usage ratio. Where's my update? Here. And I am vec2. So I think if I understand correctly, if I put -1 here and I don't know 100 here, that might work. Let's just see if that does something. Yes, that's true. Unreferenced formal parameter. I am not getting a progress. Oh yeah, should call update. That would help. I don't know, do it here. Oh yes, I ran into this last time. I can't actually call it here. It needs to be done before the imGUI render, which is why this code was here. See, that does not look really good. This looks like I'm not producing samples fast enough. Now let me see if I can, it'd be even better if I could color it. Is there a way to color? Maybe the trick is to set this frame background color. Push style color. And pop style color. Yeah, okay. So we could do something where we say, actually I'll just copy the code. We have here. In fact, I could just check the pause state technically, but anyway. Packed colors, get color, okay. Choose the given color. And then what do they have to produce this M32 color? They must have some kind of helper function to create a color. Okay. Okay. mvec4 and then the index. Okay. No? What am I doing wrong? Oh, there's actually macros. MU32. But I actually want I want a vector, right? Oh, okay, there's two kinds. M color 32. Let me just use these. Oh, look, there's even prefixed ones. That's cool. Okay. Yeah, I'm just gonna do this. And let's say like that. Let's see if that works. Yeah, I think my pop style thing's not working. While count is greater than 0. Why isn't this working? Am I not always... Oh no, okay, of course. I don't always push a color. So what I'll do is I'll always push... No, okay. Let's do it this way. What? That's odd. Am I like, oh, I think I'm choosing the wrong color. That's the background color. Okay. Let me take a look again at the progress bar function. Oh, it's the plot histogram color that I really want to change. Okay. Yeah, we don't see it. It's turning red sometimes. Okay. Let me try something else. Modulo buffer usage history dot size, and what was I using before? Was it plot lines? I liked so much. Yeah, it was plot lines. 0, 0. Scale min, scale max. Oh yeah, so we want 0 point F to 1 point F. And then let me put this how we had it, because that was pretty good. No. So we you know what we're seeing, we're not seeing like basically every time a sample gets added, we're seeing every frame. And the fact is, what we see is the pattern is that it drops and it goes up, and it drops and goes up, and basically it goes up because it gets paused and it gets a chance to fill, and then it gets consumed and it goes back up. And I don't think this is what we want to see. We want to see more of a flat line. You know what I mean? I think this is not a good pattern. I think. Not copy, and what is it again? Fill. How big is the buffer? Yeah, so the buffer, I can show you that. So set the buffer size as a function of the latency we allow. So I did this a while ago, so I don't remember. What I did is I had this desired latency in seconds. So I guess that's what, 50 milliseconds? And then I multiply that by the sample rate to get the desired latency samples. And we wait until the buffer is 50% full, so then I multiply that by 2. This made sense at some point in my mind, but this was a while ago. Let me see here. So 0.05 seconds. So desired latency samples is 2205. So we allow ourselves to be delayed by double that. because, oh well, we want to make a buffer that's at least twice the desired latency samples. So that's it. So the buffer size is going to be 4410 in terms of elements. So it's a function of the sample rate, basically. I think ultimately it's my code here that isn't producing samples at the right rate. No, the buffer size doesn't determine the latency. I mean, we could try to make it bigger, but I don't. All right, let's try. The latency is controlled by the threshold that I set. I wait until it's 50% full. By making it bigger, because I wait for it to be 50% full before actually unpausing the stream, it does increase the latency. You know what I mean? So the buffer size does affect the latency in this case. I don't understand why this is the case for this emulator. I do believe it's just that I'm not producing samples at the right rate. Like I'm close, but just not quite close enough. Let me try something. Let me try and wait till I'm 70% full, just to see what happens. And I'm going to do something else. I'll make a signal that shows 0 when we're paused and 1 when we're not paused. And I'll plot that as well. I guess it should be called not paused or unpaused. Aha. So see, we're paused quite a bit. That's what this is showing me. Basically, we're not giving the device time to actually play. It's always in a it's periodically paused, you see? Yeah, so I'm convinced I'm just not giving samples at the right rate here. Just try something. So it's almost every 34.013 CPU cycles that I need to produce an audio sample. The thing is, we know that the timing is not off because when we write to a raw file, we get something that has the right timing. So I'm pretty confident in this code. What I'm not confident is in the way I'm managing the the production of these samples at the right rate. So basically this here gets called every CPU cycle, which is, so here, you know, I kind of, it simplifies the problem a bit, right? So the source here samples is referring to the source samples, the samples from the actual emulated audio chip. And so I have this counter that counts how many of these source samples I've produced. And once I go over that, say 34.01, so I've produced, say, 35 samples. And then there is part of the problem there too, is that whole thing is not a nice round discrete number here, right? I wonder if I was, just as a test, because maybe that error is what's accumulating here. What if I was to turn this into a, you know, into if I was to floor it, basically. I'm just curious if that would actually help. Seems to have no effect. Okay, so anyway, just make sure this should have been 34. What did I just do? Yeah, okay, so that's not helping. So back to this code. So I produce, like I've now produced and summed up, say 35 of those samples. Yes, like we can even put a breakpoint and just see what happens. And see, I do take into account the fact that we have that error because num samples is actually a float. See here, we're at 35. So I produce a sample and my sample sum right now is 0 because we haven't done anything. But here, what I do is I subtract this 34.01 from my number of samples so that this now is 0.98. So the idea is that over time, the fact that we have discrete samples in terms of timing, discrete timings, or discrete samples will get corrected with this error being taken into account into the number of samples. So that's why I did that. Yeah, not really, not seeing it. One last thing I'm going to try. I'm going to try not to pause it if it goes below my threshold. Just curious what that might do. It's interesting how that changed even this curve here. Yeah, because we're not pausing, so now we're just consuming, and you can see that we're quite low. Our values are really close to 0. 0.13. Yeah, we're definitely consuming at a faster rate than we're feeding. That's pretty clear here. So why is that? Tell it we want 1024 samples per callback. One channel, sample format, which is assign 16, sample rate 44,100. I think the way this works is it tells you actually the sound card is going to be producing a two channel sound with a different format, but what you asked for is what you should be feeding it. I think that's how that works. Let me just double check. But again, you know, I've done this on this computer for my NES emulator, and I did not really have this issue. Let me see. Oh, that's interesting. So Pyro, you sent me something. Have a lookup table for the sine wave and update the sample to correct rate. Yeah, that's a good idea. We can try that. And Postal Rat, are you sure the samples coming out are changing? I'd expect some sounds, even if it's garbage. Yeah, so what we're seeing is that that we're not able to, so what I know what's happening here is that when we're not able to feed enough samples in the callback, I fill the rest with the last sample value. But most of the time it's 0, so I think that's why we're not hearing much. And every once in a while we hear a little click. But really it's because we're not feeding it enough. That's one thing too, of course, the Vectrex doesn't produce a lot of sound. Like, it's not like the NES, you know, there's always music or something playing. But I mean, we can see it on the curves. It's basically, it's starving. It's starving for data. I'm not feeding it fast enough. We know that we're producing samples. We know that when we write them to a file, they're correct, or whatever, not correct, but you know, they sort of sound like something. But we're not getting it through the sound card. So this is more of a timing issue and a starvation issue. I'm just like reading this here. I find this interesting. It's saying if you ask for a Flow 32 audio format, but sound card only supports in 16, SDL was set to hardware in 16. If you had set SDL allow format change, SDL will change the format in the obtained structure. If that flag was not set, SDL will prepare to convert your callback's float 32 audio to N16 before feeding it to the hardware. So that's kind of interesting. It's actually will do it for you, which is pretty much what I guess what I want. But I think that's what I'm doing, because it says if your application can only handle one specific data format, pass a 0 for allowed changes and let SDL transparently handle any differences. And I am effectively setting allow change to 0 because I'm zeroing the struct, right? Is it here that allow changes get set? Oh, maybe not. Where is allow changes? Oh, it's the last parameter for open audio device. Okay. So let's see. I put allow any change. Holy crap. Okay, does that sound horrible to you guys? Yeah, that sounds pretty awful, right? Okay, so that was part of the issue then. I was not getting the right, I was not getting the same format that I was requesting, and therefore I wasn't actually feeding it at the desired. I wonder what was the difference actually. Let me just take a look here. If I go back here, let's take another more careful look at the difference between desired and actual to understand where we were going wrong here. So same frequency, format is different. So maybe that's part of it. Also 2 channels. I think when it's 2 channels, you need to feed it twice the data, isn't it? Oh, yeah. Oh, yeah. That's it. Oh, hey, thanks for the raid, RW Grim. Thanks, man. Appreciate that. Yeah, that's the left-right channels. When you have 2 channels, you need to feed twice the samples. That's what's happening. So that explains it, right? Also, the format is different, so I would have had to feed it a different format. I think I saw this. So format 33056, which actually it's hex here. I want 8010 and it wants 8120. So let's see here. So we go here. So that's LSB. So there's 8010. And that's sine 16, like a little endian, I suppose, right? Yeah. And then if we looked at 8120, it wants 32-bit floating point samples. Actually, I should probably just tell it 32-bit floating point samples. I just read somewhere that asking for this was supported by all drivers. But in any case, it will do the conversion for us if we don't allow any change. And that's why. Okay, so we come back here. Hey, Olokex, what was your first language? And tell me about that keyboard. Is it good? Do you mean first programming language or first spoken language? See, now we're going to get the actual matching the desired. Yes. So now I can actually put back the paused thing. Let me see here. And in fact, we can put 0.5 again here. So as for the keyboard, yeah, actually I really love this keyboard. It's a, I wrote about it on my, oh, sorry, just give me 1 second. Well, I like the fact that it's pretty smooth here. Okay, well, this is pretty cool, right? Like, it's midnight, and I must have spent the better part of an hour and a half just staring at this code. But anyway, we've got sound. It sounds like crap, but you know, we'll fix that. So programming language. So technically, that's an interesting question. I don't know. I think first programming language, I was in 4th grade, and I programmed in Logo, that language that controls a turtle. Thanks, Pyro. Then I guess the next more real programming language was BASIC, QBasic, that I learned on, like, you know, Windows by like grade 8 or 9. And then I really seriously started learning how to program when I was around 17, and that was in Pascal. And then from Pascal, I moved to C and then to C++. And I mean, I've learned other languages since then. C#, Java, F#. I've been learning Rust recently. But I would say, like, the majority of my career has been in C++. And this keyboard, I wrote about it on my page on Twitch if you're interested to read more about it. It's the, it's called again, it's the Matthias Ergo Pro. And the reason why I got it is at the time when I was looking, I was using the Microsoft Ergonomic 4000, and over time that keyboard just got mushier and mushier. And then I would buy a replacement, and Microsoft was cheaping out on their parts. The keyboard used to cost like $60, and then they sold it for $30, and you could totally feel it. They had removed a spring on the space bar. I think just everything got cheaper, and you could totally feel it. Like after a couple of months of usage, everything was mushy. So I got tired of that, and I was like, I want something similar to the Ergo Pro, something that's split and standard layout, but with mechanical keys so that it could last a long time. And at the time, this was pretty much the only keyboard that kind of fit the bill. There are split keyboards, but not typically a standard layout. A lot of them in fact, what's it called there? The Kinesis Advantage is a split keyboard, but it's non-standard layout. It's got a lot of these keys for your thumbs. And I know it's supposed to be better for you, but I don't really feel like learning another keyboard layout. So this one is pretty good. I'm pretty happy with this one. All right, guys. Well, I'm well past the time when I usually stop. So thanks a lot for hanging out. At least we got something by the end of the stream that sounds like, what's similar to what it's supposed to sound like. And I'm very happy about that. And we have a pretty good place to continue on the next stream. So yeah, thanks a lot for hanging out, and I'll see you guys next time.